Good evening, everyone. Can everyone hear me? Those are online.
Yes, sir.
Okay. Hello, Madhurjo. What happened? Why so low? Tell me. Madhurjo, Abhigyan, what happened? Was the paper so tough? Abhigyan?
No.
So? Should have scored more. Shubhangi also, what happened? This time? Shania, you could have scored more. This paper was not that tough. What happened? Tell me.
Last 2 days I was sick, so I couldn't prepare for 2 days.
Don't you think it's an excuse? I started phase 3 syllabus long back. 2 days shouldn't affect your preparation. Will this kind of score help you in mains? Tell me, when the time comes. How will you gain confidence if you are not performing this kind of test? Tell me. You know how much of motivation is required when you're sitting for the exam, and when you're sitting for the actual exam. There's still time to improve yourself. Otherwise, it will be too late. Okay, there will be no point of turning back. Work hard. Next. In this test, the optimum score is around, if you are scoring 75, you are good. 70, 75, it's good. Because the paper is easy. If you see the paper, you will understand. Paper is not that tough. I have given tougher papers in the Bansal sheet. Bansal PDF, Bansal test which I took. The normal test which I take, chapter wise test. They are tougher. Isn't it, everyone? Which one is tougher? The chapter wise test which I take, or this one was tougher? Tell me. Everyone?
Chapter wise first.
Chapter
This
wise.
this one is easier.
First hand review of the paper. But still, Abhigyan, if it was easy only, you could have scored more. I was expecting more from you.
Yes.
There are people who have scored above 80 also. Next, Tomly, what happened? Can you hear me?
Yes, sir.
What happened? Why so less? Shamli? Tell me. What is the reason? There must be some reason, right? Shamli, can you hear me?
Yes, sir.
So, what is the reason? Do you know?
No, sir.
Shamli, I'm giving you 2 days time. You have to tell me what's wrong with you, okay? Why have you scored so low? Is it clear? Shamli,
Yes, sir.
after 2 days, I'll talk to you. Let me know what is the reason behind it. Okay, anyways, today, so some people are doing the test today. Okay, we are going to continue with functions. Okay, so let us start. So I had given some homework questions. Okay, can you people see my screen?
Yes, sir.
Okay. Okay, I had given. So these were the homework questions. No, wait. Let me see. Okay, so these were the homework questions I had given. Let me see. Find the range of tan. So this one. What? Oh, you cannot see. Okay, wait. Okay, first one is tan of pi into. So this one was elemental 0, right? Everyone got elemental 0. First one. First one is elemental 0. Everyone got it. Next, second one is closed open 0, 1. Right? Everyone got this. Next one is I guess 1, root 2. Tell me. Anyone having any doubt? You can ask me now. Tell me. Anyone having any doubt? Okay, and Shinika, you're joining after so long. Okay, go through all the notes. Okay, solve the homework questions.
Yes, so I've seen all the recordings and I've gone through all the notes as well.
Okay. Next, I guess this is 1, 2 close. Let me see. This is the range 1, 2 close. Okay. So next one, y equal to x square plus 2x minus 11 upon 2 into x minus 3. This one I have to check. X square plus 2x minus 11 upon 2 into x minus 3. Okay. Quadratic upon
Second is
mean.
solved.
Oh, this one. So you have a doubt. Let us start. Y equal to x square plus 2x minus 3. Everyone pay attention. Upon 2x minus 11 upon 2 into x minus 3. This is question number. Whatever question. What question it is? This was part 4 actually. This was part 5. Part 5. Everyone, part 5. So began in quadratic equations, we have done this kind of questions. Okay, x is a real number. Let us cross multiply. You will get 2y into x minus 3. 2y into x minus 3 is equal to x square plus 2x minus 11. This implies x square plus x common will get 2 minus 2y minus 2y will go plus 2y minus 11 is equal to 0. Right, tell me Abhigyan, are you getting?
Yes, sir.
Yes, 6y. Wait, 2 minus 6y. Okay, now since x is real, wait, 2x, how this one was okay. Wait, 2 into 3 minus 6y. Yes, 6y. 6y minus 11. Okay, now since x is real, x is a real number, discriminant should be greater than or equal to 0. Right, tell me everyone. That is 2 minus 2y whole square minus 4 into 6y minus 11 must be greater than or equal to 0. What are we getting? Yeah, we can divide by 4 on both sides and expand 1 minus 2y plus y square minus 6y plus 11 must be greater than or equal to 0. This implies y square minus 8y plus 12 must be greater than or equal to 0. Okay. So Abhigyan, y minus 2 into y minus 6 is greater than or equal to 0. Yes or no? This implies y belongs to minus infinity comma 2 union 6 comma infinity. Is it clear, Abhigyan? Tell me.
Yes, sir.
Next. So the answer is minus infinity comma 2 union 6 comma infinity. Okay, find the domain of over here 3 comma infinity. Anyone having any doubt, tell me. You can ask me now. Over here the answer is 3 comma infinity. Next, f of x is equal to x. We need to find out the remainder. Remainder is 2x plus 1. Anyone having any doubt, you can ask.
Second is called number 3.
Number 3, okay. Okay, number 3, f of x is equal to this. We need to find out the remainder when it is divided by x cube minus x. So who asked? Abhigyan?
Yes, sir.
Abhigyan, f of x is divided by cubic. So what kind of a remainder you will get? Tell me. Tell me, Abhigyan, what kind of a remainder you will get?
Real number.
A real number. There is some noise coming from your end. Whenever a polynomial is divided by a quadratic polynomial, remainder is what? Cubic, linear, right?
Yes, sir. Linear.
And whenever a polynomial is divided by a cubic polynomial, then remainder is quadratic, right? One
Yes.
less than the divisor. So I can say that f of x is equal to x to power 135 plus x to power 125 minus x to power 115 plus x to power 5 plus 1 must be equal to x cube minus x into q of x plus ax square plus bx plus c. Tell me. Are you getting Abhigyan? Yes or no?
Okay, sir. Got it.
Now, in order to get the remainder, this part should vanish. That means we need to substitute x cube minus x equal to 0. If x cube minus x equal to 0, x equal to 0, 1, comma minus 1. Right. So let us start substituting. F of 0 is equal to 1, which is equal to c. So I've got the value of c. C is equal to 1. Next. Let us substitute f of 1. F of 1 is equal to 1 plus 1 minus 1 plus 1 plus 1. This will give us how much? Tell me. 3, right? Which is equal to a plus b plus c. C is equal to 1. This implies a plus b is equal to 2. Let me see. I'm doing it correctly, right? 1 plus 1. 3. F of minus 1. F of minus 1 will be equal to. Okay, have I made a mistake? Right only. Okay. F of minus 1 will be equal to minus 1 plus 1 minus 1 minus 1. Sorry, plus 1. This will be equal to a minus b plus 1. This implies a minus b will be equal to plus 1 gets cancelled from both sides, and minus 1 plus 1, a minus b is equal to minus 2, right? So I've got a plus b is equal to 2, a minus b is equal to minus 2, right?
Yes.
So a plus b, let us substitute, is equal to 2. When you add, okay, you'll get a equal to 0. This implies b is equal to 2. Therefore, the remainder is, tell me, Abhigyan, are you getting?
Yes, sir.
Plus 2x plus 1, which is equal to 2x plus 1. This is your remainder. Tell me, are you getting, Abhigyan?
Yes.
Okay, next. We need to check whether the functions are following functions are identical or not. Let's see. Okay, cot square x into cos square x. Identical. First one is identical. Second one is signum function of x square. No, tan square x into sin square x. Let's see. Identical. 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 Achha, no, not identical. Number 5. Not identical. Right, domain. Not identical. 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 Not identical. If there's anyone having any doubt, you can ask me now. Tell me.
Sir, can you explain why the seventh one is not identical?
F of x is equal to e to the power ln e to the power x. That one.
Yes, sir.
Okay. What is the domain? First of all, tell me. Domain is x greater than or equal to 0? Greater than 0?
Yes, sir.
Okay. Okay. Number 7. Domain is, for domain, e to the power x must be greater than 0. This implies x should also always belong to real. Okay.
Yes, sir.
And same thing is happening over here. Okay. Now e to the power ln e to the power x. This will be equal to e to the power x only. Okay, which is g of x. Therefore, they are identical. Right, tell me.
Okay, sir. I understood.
Number 9. Not identical. Number 10. Identical. Okay, number 6 came in JEE mains 2025, 194. You people got 194. Tell me. Anyone having any doubt? You can ask me now. Tell me.
The cancel number 6.
Number 6. So the range of the function f of x is equal to 5 minus x upon. So just now similar kind of problem we solved, isn't it? Similar, totally similar.
Yeah.
Right, tell me. And you only asked.
Yes, sir.
Yes. Number 6. Y equal to 5 minus x upon x square minus 3x plus 2. Okay, let us solve. So over here, x square minus 3x plus 2 into y is equal to 5 minus x. Right? This implies, what are we getting? X square into y plus x into 1 minus 3y plus 2y minus 5 must be equal to 0. Right, everyone? Tell me. Abhigyan, are you getting?
Yes, sir.
Now there are two cases. Case 1. When y is equal to 0. When y is equal to 0, what will happen? Tell me.
We'll get a linear expression.
No. When y is equal to 0, this part is gone. This is gone. When will this be equal to 0? When the denominator is infinity.
Yes.
That is x square minus 3x plus 2 is equal to infinity. Or x is equal to? Oh wait, sorry. Either x square minus 3x plus 2 is equal to infinity. Yes, it can be infinity. This is x belongs to real. Or 5 minus x is equal to 0. Yes, correct. 1 by something constant by infinity is equal to 0, and the numerator is equal to 0. Yes. So over here x is equal to 5. Yes. So we are getting it. That means y equal to 0 should be included. Okay. Can be included. Case 2. When y is not 0. Then what will happen? Putting discriminant. Discriminant is 1 minus 3y whole square. B square minus 4y into 2y minus 5 must be greater than or equal to 0. This implies 9y square minus 6y plus 1 minus 4 to the 8y square minus plus 4 5 the 20y must be greater than or equal to 0. This implies y square minus 6y plus 20y, that is plus 14y plus 1 must be greater than or equal to 0. What? Huh? Wait a minute. This is the quadratic. Wait. Wait, what are they asking us? Acha, x is not equal to 1, 2 minus infinity, alpha union beta, infinity. So basically we need to find out alpha square plus beta square. What is alpha plus square? What is alpha square plus beta square? This will be equal to alpha plus beta whole square minus 2 alpha beta. You can see alpha plus beta is equal to minus 14 and alpha beta is equal to 1. So this will give us how much? 194. Yes, like this you will get 194. So the point is over here we don't have to solve the quadratic. We have to look at the roots only.
When did we check for when y is equal to 0? They gave the range only. It doesn't really.
Actually, we have to include all possible values. So y equal to 0 will also be included. Okay, but I think why
format they gave, like they said the answer will be the form minus infinity to like beta comma.
Sir, y is equal to 0 will be valid.
So even if that is not included, like it would somehow get included.
hi, it would somehow get included. Okay. Tell me, those who are online, are you people getting?
Yes.
Okay. Yes. Okay, Joytra, you understood? Okay, I think you have solved it, right? Okay.
No, sir.
Cheers.
Last one I haven't. Yep.
Oh. So have you understood this one?
Yes, sir.
Shomili, Shubhangi, Shreyasi, is it clear?
Yes, sir.
Yes.
Okay. So I think we can continue. This was the last problem. Let us continue. Okay, what was the last sum we did? Okay. Question number 1. State whether the following functions are identical or not. State whether the following functions are identical or not. Number 1. F of x is equal to 1 upon x plus 1 by x. G of x is equal to x upon 1 plus x. Okay. Number 2. F of x is equal to box of fractional part of x and g of x is equal to fractional part of box of x. Solve. Okay, once you have done it, send your answers quickly. You have to tell me whether they are identical or not. Done. Oh, I think you are correct. Over here there is some mistake. No, you are correct. You are correct. You are correct. You are correct. Those who are online, send both the answers at once. Yes, Adija, your answer is correct. Adito, your answer is correct. Shujita, your answer is correct. Quickly send everyone. Shana, is it done? Quickly.
Excuse me, sir.
Yes, tell me, Shujita.
Sir, you told that from April this class is going to end at 8.
Huh. Yes, yes, yes. Okay.
Sir, actually I had the tuition as I informed you earlier from 8.
No, actually it was only up to April only. Right. To April we
sir.
were doing the classes till 9. Okay.
Sir, then when will this class end?
8:15. Okay,
So this
around
will
8.
end at 8:15.
Yes.
Okay, sir, then that's okay.
Especially for the fishing, you get forms of apply.
Forms are not. Why? Yes, yes, yes. Of course, of course, of course. Yes, Olive, right answer. Adito, check part 2. Oh no, wait. It's not Adrito, I guess. Rishabh, check part 2. Part 1 is correct. Shinika, part 1 is correct. Abhigyan, both are correct. Rasheshwari, both are correct. Ronak, both are correct. Adito, both are correct. Madhurjo, both are correct. Adrija, check second part. Shinika, second part is correct. Shamli, both are correct. Shubhangi, both are correct. Aipsha, both are correct. Agniba, both are correct. Jayatra, both are correct. Okay, so first one I am solving. Tell me.
Not identical.
Not identical. Okay, number 1. Okay. First of all, see, domain will be, okay, domain of f will be equal to r minus elemental 0, right? And what is the domain of G? R minus elemental minus 1. Okay, next, number 2. F of x is equal to box of fractional part of x. Okay, what is the domain? Domain of f will be all real. Domain of G will also be all real, right? Tell me. What is box of fractional part of x? 0, right? F of x is always 0. Next, what is the fractional part of the greatest integer? It's an integer, so g of x will also be equal to 0, right? Tell me, everyone. Therefore, they are identical. First one is non-identical. This one is identical. Anyone having any doubt? You can ask me now. Okay. Adija, you understood the second one?
Yes, sir.
Okay. Next, Rishabh, you understood?
Yes, sir.
Next, our next topic is classification of functions. Although we have done it before, but still, so it's like revision. Classification of functions. Number 1, 1 function. Okay, or you can say injective mapping. One function or injective mapping. A function f maps A to B is said to be 1 1. Is said to be 1 1. Or injective mapping. Or injective mapping if different elements of A have different f images in B. Okay, that is, if f of x1 is equal to f of x2, this implies x1 is equal to x2, and vice versa. Okay, if f of x1 is equal to f of x2, this implies x1 is equal to x2, and vice versa. So I draw some mapping. Okay, this is A, this is B. Okay, so what do you think? This is injective? What do you think? This is injective? Next. Those who are online, what do you people think? Is this injective? The first one? This is injective, right?
Yes, sir.
Okay. Next. Second one. Is this injective? What do you think? Those who are online, anyone raise your hand, tell me. Acha, no.
Sorry, sir.
Okay. Next, another one. Okay, you people raise your hand and tell me. Those who are online. Is this injective? Those who are online, tell me. Those dots mean they are not mapped. Okay. Those dot means they are not mapped. Yes, Rishabh, tell me.
This is the injective.
They are injective. Okay. Even if the two elements do not have a pre-image, it doesn't matter. Right. Next. Acha, over here, you people can understand that the range is a proper subset of codomain. Right, everyone? Over here, range is also a proper subset of codomain. Next. I'll give you an example of an injective mapping. Let F maps R to R be such. Let F maps R to R be such that f of x is equal to x plus 1. So everyone, over here, f of x1 is equal to f of x2. If I substitute f of x1 is equal to f of x2, okay, this implies x1 plus 1 is equal to x2 plus 1. Okay, 1 gets cancelled. We'll get x1 is equal to x2. Okay, therefore f is 1. Okay, next. What do you think? Raise your hand. F of x is equal to e to the power x. Is it 1? Raise your hand. Tell me. Yes, Rashishwari, tell me.
Yes, it is 1.
It is also 1. Okay. That is, if e to the power x1 is equal to e to the power x2, this implies x1 is equal to x2. Okay. Next. What do you think? F of x is equal to x cube. Is it 1? Raise your hand. Tell me. F of x is equal to x cube. Yes, for this one, Joytra, tell me.
Not 1.
Not 1. Adrija, tell me.
Sir, it is 1.
Yes, Joytra, can you tell me why did you say it is not 1?
Like if x1 cube will not equals x2 cube, I guess that's.
No. Actually, see, when you substitute f of x1 cube, f of x1 is equal to f of x2. This implies x1 cube is equal to x2 cube.
Okay.
Right.
Yeah, I thought something.
This implies there is only one possibility, right? x1 is equal to x2. Next. Just tell me. Somebody tell me, raise your hand. F of x is equal to x to the power 8. Is it 1? Raise your hand. Yes, Ritam, tell me. No. It's not 1. Okay? It's not 1. So I'm going to generalize this. Everyone pay attention. Generalization. If x1 to the power 2n minus 1 is equal to x2 to the power 2n minus 1, this implies x1 is equal to x2. Okay, everyone? If x1 to the power 2n minus 1 is equal to x2 to the power 2n minus 1, this implies x1 is equal to x2. Hence, we can say f of x is equal to x1, x to the power 2n minus 1 is always 1. Next, how to understand methods of identifying an injective function. Okay, methods of identifying an injective function. Method 1, using graphs. Okay, so graphical method, everyone pay attention. If a line parallel to x-axis cuts the function, cuts the graph of the function, at least at 2 points. Okay, then f is many one. Okay, everyone, f is many one, that is not 1 1. Tell me, are you people getting? I'll give you an example. For example, f of x is equal to sin x. Okay, everyone, how does the graph of sin x looks like? The graph of sin x looks somewhat like this, keeps on going like this. Tell me, will you be able to find a horizontal line that will cut the graph in at least 2 points? Yes or no? You will be able to find
Yes,
it. Okay, right? Any line, I don't know what is. Okay, let us say that this line is y equal to half. Okay, can anyone tell me what is the coordinates of this point? If this line is y equal to half, what is the coordinates of this point? Tell me. Quickly tell me. This is the graph of sin x. Exactly. This line is pi by 6 comma half. But not only this line. What is this? What is this point? Tell me. That is 5 pi by 6 comma half. Right. So what you can see is, you see in this mapping, this is pi by 6, this is 5 pi by 6, and this is half. See, the mapping is converging. Are you able to understand? So for two distinct values of x, you are getting the same value of y. That is why it is many one, not 1 1. Here we can see that y equal to half cut sin x at least sin x in at least 2 distinct points. Okay. Question number 1. Acha, you people have to raise your hand and say, okay, no need to send me the answers. Raise your hand. Question number 3, I guess, right? What is it? 3. Find whether the following functions. 2. Question number 2. Find whether the following functions are 1 1 or not. Okay, you have to raise your hand. Okay. Number 1, y equal to box of x. Raise your hand. Don't speak up in between. Raise your hand. Y equal to box of x. Is it 1 1 or not? Yes. Rishabh, tell me. Y equal to box of x.
So many one.
Y equal to box of x is many one. Why? You can see if you draw the graph, box of x looks somewhat like this. Tell me. Will you be able to find a straight line parallel to x-axis cutting this graph in at least 2 distinct points. Tell me, what do you people think? Tell me, everyone. You see the purple line, y equal to 2, cuts the graph in infinitely many points, right? Tell me, is it clear? Those who are online, tell me, Abhigyan, Oipsha, is it clear? Joitra, Shayasi, Shwankit, is it clear?
Yes, sir.
Number 2, tell me, y equal to fractional part of x. Raise your hand. Is it 1, 1, many 1? Tell me. Y equal to, yes, Ritam, tell me. Many 1. It's many 1. Okay. Why?
Hello, sir.
Yes, tell me. Shwankit.
Sir, I joined just now. So can you please show me how many pages I have to leave before this?
Wait, just give me 1 minute. I'm drawing the graph. So tell me, over here also, will you be able to find a straight line parallel to x-axis which will cut the graph at 2 distinct points? Tell me. Yes, you see? Purple line. Yes, so Shwankit, I have started from, let me see. Okay, I started from where? From here. Okay. Means page number 84. Means I've done 7 pages till now. Okay.
Sir, are these the types of functions you're doing?
Types of functions.
Okay, sir.
Next. Number 3. Raise your hand. Y equal to 1 by x. What do you think? 1, 1 or many 1? Raise your hand. Yes, for this one, Shita, tell me.
1, 1.
It's 1, 1. 1 by x is 1, 1. It's very simple. Why? Because it will be a hyperbolic graph. Right, everyone? Tell me. Like this. It will be a rectangular hyperbola in the first and the third quadrant. Okay, it's many. You won't find a straight line which will cut the graph at 2 distinct points. It's many 1. 1, 1, 1. Number 4. What about y equal to 1 by x square? Tell me. What about y equal to 1 by x square? Raise your hand. Yes, Anvesha, tell me.
Many one.
It's many 1, right? As you can see, 1 by x1 square, if you write it as 1 by x2 square, this implies x1 square is equal to x2 square. This implies x1 is equal to plus minus x2. Next. Huh? Wait a minute. If you want to draw the graph y equal to 1 by x square, okay, it will not be hyperbolic. Domain is r minus 0. Okay, graph is always positive. That means it will be in the x-axis. Above x-axis. Next, y equal to 1 by x square will look somewhat like this in the first quadrant. Right? Tell me. Somewhat like this. Okay, maybe the curve is not proper. Okay, but somewhat like this. Now the function is even. So same thing, you draw it on the left hand side. Isn't it? Tell me. I think this will be the graph. Let me check it once. I think this will be the graph. Okay. Don't know. Shall we check it? The function is even. It will be totally above 1 by x square. Oh yes. See. Is it clear? Okay. Next. So over here you can easily find a straight line parallel to x-axis that will cut the graph at two distinct points. Next, another one. Number 3. Oh wait. Number 5. Raise your hand. Acha, number 5 so we already know y equal to sin x is many one. Number 6. Y equal to cos x is also many one. Number 7. Y equal to tan x. Raise your hand everyone, tell me. Y equal to tan x. Tell me. Raise your hand. Yeah, Shashwata, tell me.
So many one.
Many one. Next. Number 8. Y equal to x. One or many one. Tell me. Yes, Adrija, tell me.
Sir, 1, 1.
Is 1, 1. Very simple. It's a straight line, right? Number 9. Number 9. Y is equal to x square. This we already know. It is many one. Number 10. Y is equal to x cube. Just now we have seen is 1, 1. Number 11. Y is equal to mod x. Raise your hand. 1, 1 or many one. Mod x. Yes, for this one. For this one, Shamili, tell me.
Sir, many 1.
It's many one. Okay, number 12. Y is equal to signum function of x. 1, 1 or many one. Raise your hand. For this one, Joytra, tell me.
I raised hand for the previous.
Oh, acha. Okay. Rishabh, tell me.
So many one.
Many one. Last one, number 13. Y is equal to e to the power x. Raise your hand. 1, 1 or many one. Tell me. By this time, all the graphs should be there in your head. Okay, Oipsha, tell me.
1, 1.
You 1, 1. Okay, you won't find a straight line which will cut the graph at two distinct points. Next. Method 2. Method 2. By differentiating. Okay. How we can understand that it is many one. So if people know the meaning of dy by dx, dy by dx actually gives us the slope of the tangent at a particular point, right? Like if this is the curve y equal to e to the power x, okay, this is the curve and this is the tangent, okay, and if this is theta, then tan theta, let us call this point as 1, e, okay, then tan theta is will be equal to dy by dx, right? You people know the meaning of dy by dx, right? Next. So how to understand? I mean, how will we understand whether a function is injective or not? Through differentiating. Okay, for this we need to understand what is local maxima and local minima. Okay, what is local maxima? Pay attention. Local maxima. Maximum value of the curve. Maximum value of the curve in a particular interval. Okay, is local maxima. Pay attention everyone. If this is the curve, okay, I'm going to draw tangents at distinct points of this curve. Okay. This is a tangent to the curve. Okay. Next, this is another tangent to the curve. This is another tangent to the curve. Okay. This is another tangent to the curve. And this is another tangent. To curve. Okay. Acha, see everyone. This is the maximum point. Right? Can you people understand? So this point is known as local maxima. Why it is known as local maxima? Because in a particular interval, this is the highest point, peak point of the graph. Okay. And this is the tangent line at local maximum. Tangent line at local maxima. Okay. Next, everyone, pay attention. Here we can see. Here we can see that the tangent at local maxima, the tangent at local maxima is a horizontal line, parallel to x-axis. Okay, so dy by dx at local maxima will be equal to 0, right? Also, you see this angle is, let us call it as theta, and let us call this angle as alpha. Okay, this point local maxima, let us call the local maxima as a comma 0. This point is a comma 0. Okay, so here we can see that all the tangents wait, before writing it I am showing you. Okay, see everyone, if you draw a tangent before a comma 0 to this graph, the tangent will always make an acute angle. Can you see? If you draw a tangent at this point, it's acute. If you draw a tangent at this point, it's acute. If you draw a tangent at this point, it's acute. Are people getting? After a comma 0, the tangent is obtuse. Can you people understand? Those who are online? Avipsha, Agniba, are you getting?
Yes, sir.
Shashato, Rishabh, are you getting?
Yes, sir.
Yes, sir.
Okay. Shubhangi, is it clear?
Yes, sir.
Okay. So here we can see that all the tangents before point a comma 0 makes acute angle with x-axis. Okay, hence dy by dx is equal to tan theta will be greater than 0, right? Dy by dx will be greater than 0. So before a comma 0, the function is increasing. After a comma 0, the function is decreasing. Can you people understand? While we can see that all the tangents after point, after point a comma 0 makes obtuse angles. Makes obtuse angle. So dy by dx will be less than 0. Okay. So see everyone, if I draw a number line, this is point A. Okay. This is how the sign changes from plus to minus. Okay. So you can write it down. Thus, if there is a sign change, from positive to negative, from positive to negative of dy by dx at a comma 0, then local maxima exists at x equal to a. Is it clear to everyone? What is the meaning of local maxima? Okay. Local maxima is a comma 0 only. I have marked a comma 0 as the peak point. See in the graph.
But that is the point that is like perpendicular to the x-axis, that is the foot. Why are we not considering that highest point?
At x equal to a, we are getting the local maximum.
So we can consider that point also.
But I couldn't understand what you are trying to
No,
say.
like we are considering everything according to a comma 0. Why not that highest point?
We are considering highest point only. At x equal to a, the local maxima exists. That's what I am saying. Okay, like in this theory portion only. So wait, I should have written at x equal to a. Okay, local maxima exists at x equal to a. It's fine. Okay, means everywhere I am trying to mean that at x equal to a, local maxima will exist. Okay, we'll get the peak point of the graph.
F of A is maximum.
F of a is maximum.
That is.
Understood? Those who are online, are you people getting? Wait, tangent after point a comma. Wait, after point a comma 0 only makes obtuse angles. Okay. Okay. Means I mean to say that at x equal to a, the local maxima exists. Okay. Those who are online, are you people getting? Abhigyan, Rasheshwari, Anvesha, Adrito, Madhurjo, are you people getting?
sir.
Arif,
Yes,
are you
sir.
getting?
Yes.
Yes, sir. Yes, sir.
Okay. Achha, so everyone, what is the point of getting a local maxima? I mean, why we are considering local maxima in injective function? Okay. So everyone, if a function has local maxima, okay everyone, if function has local maxima, then what will happen? The graph will look somewhat like this. So are you able to find, I mean, will you be able to find a horizontal line which will cut the graph at two distinct points? Yes.
Yes, sir.
So the function will become many one if local maxima exists. Okay, so we cannot say that the function is entirely increasing in its domain or entirely decreasing in its domain. Okay, so write it down. Then there exists a horizontal line. Then there exists a horizontal line which cuts the curve, in at least two distinct points. Two distinct points. Thus, the function becomes many one. Okay. Next, So same thing will happen with local minima. Right, everyone? Local minima. What is local minima? Minimum value of a function. Minimum value of the curve in a particular interval. Minimum value of the function in a particular interval. So this is the curve where we'll get local minima. This is point A, x equal to A. At 2-3 places I'll draw tangents. This is one tangent. Okay, this is one tangent at A, x equal to A. And this is another tangent at x equal to, after x equal to A. Okay. So everyone, if this is theta, this is alpha. You can see alpha is obtuse, theta is acute, right? So here we can see that the sign changes, that the sign of dy by dx changes from negative to positive. Right, everyone? The sign changes from negative to positive about a point A. About a point A. Okay. Then local maxima exists at.
It's a minima.
Oh, local minima. Minima exists at x equal to A. Okay. Again, same thing. So what will happen? So if a function has local minima, if a function has local minima, then it is many one, like this. Are people getting? Anyone having any doubt, you can ask me now. Next. Also you see that if dy by dx is always greater than or equal to 0 for all x belongs to domain. If dy by dx is always greater than or equal to 0 for all x belongs to domain, okay, this implies function is 1 1. Okay, everyone. Or if dy by dx is always less than or equal to 0 for all x belongs to domain, this implies the function is 1 1. Okay. Now you people can say, sir, what? Wait, greater than or equal to 0, less than or equal to 0. You people can ask, sir, you have written dy by dx is equal to 0. When dy by dx is equal to 0, the function can become many one. Right? For example, y is equal to 5, a constant function. So y equal to 5 is a constant function. Y equal to 5 is 1 1 or many one? Tell me.
1 1.
1 1? Many one.
Anyone?
Y equal to 5 is many one. Okay. But try to understand, those things will happen for constant functions. Are you getting? Those things will happen for constant functions. Okay. But for the curves, okay, at a particular point it can happen that dy by dx is equal to 0. For example, y equal to x cube. Okay. So what is y dash at 0, 0? Tell me, everyone. What is y dash at 0, 0? 0. Okay. But still, can I say that y equal to x cube is injective? Tell me. Can I say y equal to x cube is injective? See, y equal to x cube is injective. At a particular instant, that instant is origin. At a particular point, the function slightly becomes parallel to x-axis. Okay, the tangent becomes slightly parallel to x-axis. Actually, over here, the tangent is x-axis only. Okay, you will understand in AOD, 0, 0 is a point of inflection. Okay, but anyways, I hope you people can understand why I have written dy by dx is greater than or equal to 0 or dy by dx is less than or equal to 0. Tell me. Those local maxima does not exist on, right?
Sir,
Local
the
maxima.
dy by dx should not be equal to 0.
Wait.
If you take an internal definition, you get a local maximum, right?
Where?
Condition of
In which one?
maximum is
In which
if you
one?
take a domain of x, then you will get a.
In a particular domain only we check. Okay.
So if I take a domain from -2 to 3, I will get a local maximum.
Over here? No. Try it out. Try it out. Will not
Local
get it.
maximum will be the point where tangent is 0. That's not zero.
Yes. You will get y dash is equal to 3x square. Right. 3x square is equal to 0 only at one point. Isn't it? Right. So you will never get a local maxima or local minima. At a particular instant 0, 0, okay, the graph slightly, the slope of the tangent slightly becomes parallel to x-axis. But after that, again it increases. Okay, that point is known as the point of inflection. We'll learn it later, not now. Anyways, yes, Shubhankit, tell me.
Sir, dy by dx should not be equal to 0, right?
Not be equal to 0. What is dy by dx? Over here, x cube. Tell me.
X cube is 3x square.
3x square. And what will be dy by dx at 0, 0? When you substitute x equal to 0, what are you getting?
I get 0.
0. Are you getting? Why are we are getting 0 over here? Tell me. Hello, Shubhankit, are you getting?
Yes, sir.
Okay. I'll give some example. I mean,
Sir, if the maxima exists and maxima or minima exists, then the function will be many one.
If the maxima
Right.
exists, maxima exists, function will become many one.
If the maxima exists, then at that point the dy by dx should be 0.
Dy by dx. Not only that, we need to check for the points around it also. That is, the sign should change. I've written it, right? See, from negative to positive. Exactly. Are you getting? You have to also check whether the sign changes or not. If the sign is changing, then only the maxima exists. Yes, double differentiation will also work. Okay, if you double differentiate, but sometimes what will happen, the double differentiation will also become 0. Then in that case, how will you check? You have to check whether the sign changes or not. Are you getting? I'll give you an example that the double differentiation also becomes 0. You see this example only. What is dy by d2y by dx square at 0, 0? Tell me, Ritam. 0 only, right? So d2y by dx square test will also fail over here. So the only way possible is to check the change of sign around point 0. Understood? Around a particular point. Hey, Shubhankit, tell me.
Sir, if dy by dx is greater than or equals to 0, then also it is 1, 1. And if it's less than or equals to 0, then also it's 1, 1. Then
Yes.
means dy by dx belongs to real numbers and it's 1, 1.
Belongs to real numbers. No. You didn't understand. These two are different cases. Okay, they are not the same case. Are you getting? These two are different cases. This means that the function is always increasing. This means that the function is always decreasing. So you will not get any point of maxima or minima.
Oh, okay, sir. Okay, sir. Understood.
Like this. Okay,
Yes,
they both are
understood.
different cases. Don't combine them. Okay. Yes, those who are online, are people getting? Anyone having any doubt, you can ask me now. Shashwato, Shrijita, Shersi, Shubhangi, Shamali, Shinika, are you people getting?
Yes,
Rishabh,
sir.
Ronak,
Yes, sir.
Yes, sir.
Yes, sir.
Joyatra, is it clear?
Yes, sir.
Agniba, Adrija, is it clear?
Yes, sir.
Yes, sir.
Injection positive to negative. What is tangent to positive, negative, and unknown?
So there are two. By looking at this, you don't understand it is many one.
Okay.
See, in your wavy curve only there was answer. Okay. Anyways, pay attention, everyone. I'll give some examples. Okay. Number one. So this is y equal to e to the power x, everyone. Right? Tell me, everyone. This is y equal to e to the power x. Achha, what is y dash, everyone? This is y equal to e to the power x. What is y dash? Y dash is equal to also e to the power x, right? Tell me. Over here, wherever you are drawing tangent, pay attention. Wherever you are drawing tangent, what are you getting? The angle created by the tangent will always be acute. Can you ever find out a tangent which will be obtuse? Tell me. Is it possible to find out a tangent which will be obtuse? Tell me, everyone. No, not possible. Okay. So over here the function is always increasing. Hence dy by dx will always be greater than 0. Over here, dy by dx is always greater than 0 for all x belongs to real. Hence, e to the power x is many 1. The best way to check whether the function is 1, 1 or many 1 or not, okay, to draw the graph. You people know how to draw the graph, find out some points, check the continuity, discontinuity. Oh, sorry, 1, 1. Okay. Next, I'll give you another one. Number 2. Y is equal to ln x. This is how the graph looks like. Wherever you draw the tangent, you'll always get an acute angle. Okay. Either you should get acute or you should get obtuse. Okay. For a decreasing function, also it will happen. Okay. Y equal to log x to the base half. Okay. Y equal to log x to the base half. This is also 1, 1. Right. How will the graph look like? The graph will look somewhat like this. Right. Tell me, everyone. Wherever you draw the tangent over here, wherever you are drawing the tangent, the slope of the tangent is obtuse. Right. Tell me, everyone. The slope of the tangent is always obtuse. Okay. Next. Note. I think last day we did one problem, right? F of x is equal to 1 upon x plus 1 whole cube minus 3x plus sin x. We did this problem, isn't it?
Yes, sir.
Right. And I drew the graph. If you people check my notes, I drew the graph also. Okay. X equal to minus 1 will be the vertical asymptote. Okay. And the graph was looking somewhat like this. If you will check, I'm not drawing the graph once
Yes,
again.
sir.
The graph was looking somewhat like this. Achha, over here, this function is many 1, right? This function is many one. Okay, even though it is decreasing, right? It is always decreasing, right? Pay attention. So just now, what did we do? We were checking the monotonicity of the function, whether it is increasing or decreasing. Okay, then we could say that no maximum minima exists, and hence the function becomes 1 1. Okay, but now what has happened? I've got an exception, right? Over here the function is many one. Okay, even though the function is always decreasing, you see, the function is always decreasing from left to right. Are people getting? So now how to check? The only way to check would be to find out its continuity also. I mean, to find out. To find out its. Wait, I'm telling you. The only way to check whether the function is 1 1 or many one is to find its value around the discontinuous point. Okay. After finding out the value, you can just draw the graph and check. Are you people getting? So ultimately, you have to think about drawing the graph only. Okay. 10x, same thing. Okay, let me solve. Let me complete. Okay, decreasing function. As there is a point of discontinuity. If the function is always continuous, then you don't have to check it again. Then you don't have to draw the graph. Okay. But for a continuous function, discontinuous function, you always have to check. Okay, decreasing function as there is a point of discontinuity. Tell me. Those who are online, are you people getting? If you have any doubt, you can ask me. Tell me, Avipsha, Avigyan, Madhurjo, Rishabh, everyone understood? Shrita, Shashwato, is it clear?
Yes.
Shesi,
Yes, sir.
Shubhankit, is it clear up to this much?
Yes, sir. Clear.
Okay. Also write it down.
Scroll up a bit.
Yes. If dy by dx is greater than or equal to 0.
Sir,
Yes, tell me.
sir, can you show where is the point of discontinuity?
This is the point x equal to -1. Right, you see x
Yes.
equal to -1 does not satisfy.
Okay, sir.
Okay, for all x belongs to domain. If dy by dx is greater than or equal to 0 for all x belongs to domain, then the function is monotonically increasing. Okay. Next. And if dy by dx is less than or equal to 0, then function is monotonically decreasing. Okay, question number 3. 3, right? Find whether the following functions are 1 1 or not. Number 1, y is equal to 2x plus sin x. Number 2, y is equal to e to the power x plus x. Number 3, y is equal to x minus 1 into x minus 2 into x minus 3. Number 4, Okay, solve these three only. Solve quickly. Arif, have you understood up to this much?
Yes, sir.
Okay. Yes, Arif, your answer is correct. Rishabh, check part 1. Done. First one, see the first one, second one is correct. Third one is also correct. First one, the second one is correct. Third one is also correct. First one is correct. Yes, man, what happened? What is there to talk? Yes, Agniva, right answer. Adito, right answer. Shubhankit, check the first part. Others are correct. Shashwata, your answer is correct. Ronak, your answer is correct. Shinika, part 1 and 2 are correct. Okay, Shirta, your answer is correct. Shubhangi, your answer is correct. Anvesha, your answer is correct. Shamri, your answer is correct. Abhipsha, your answer is correct. Shijita, your answer is correct. Adrija, your answer is correct. Abhigyan, check the second one. Rasheshwari, your answer is correct. Everyone pay attention. Part 1. Y equal to 2x plus sin x. Y dash will be equal to 2 plus cos x. Right, everyone? Y dash is equal to 2 plus cos x. Okay? So see, what is the range of cos x? -1 to 1. Right. Can you people understand that this is 2 plus -1 comma 1? And this is always greater than 0. Right. So people can understand it's always greater than 0. So y dash is greater than 0. This implies the function is always increasing. right? Function is always increasing. I'm drawing it. Huh? Probably. I think same kind of graph I will draw. Okay, hence the function is many one. Sorry, one. Acha, so you people must be curious how will the graph look like. Okay. So I've got f dash, it's increasing. This much we have got it that it is increasing. Okay. What is f of 0? F of 0 is equal to 0. That means the graph also passes through origin. Now my task is to find out whether the function will be concave up or concave down. Right. If it's concave up, I'll draw concave up. If it's concave down, I'll draw concave down. And I just have to maintain that it is always increasing. Understood? So in order to understand whether it is concave up or concave down, I'm going to find out f double dash. Okay. What is f double dash? Tell me. What is f double dash?
So minus sin x.
Minus sin x. Right. Sure. So minus sin x is at some point it is increasing. At some point it is positive. After some point it is negative. Right. So minus sin x is greater than 0. When is it greater than 0? I'll just draw one part of the graph. Okay, it's greater than 0.
When sin x is less than 0.
When sin x is less than 0, that is from pi to 2 pi. Right, everyone? Tell me. Are you people getting? From pi to 2 pi. Okay. Next. So from pi to 2 pi, we need to draw concave up graph or concave down graph. Tell me. Concave down? Okay. And where it is less than 0? Tell me. It is less than 0? No, concave up graph, not concave down. It is less than 0 from 0 to pi, right? Tell me. So let us draw. So from 0 to pi it will be concave down. After that concave up, then concave down. Okay, it keeps on going. Huh? Somewhat like this. Okay, I mean, are you people able to understand how the graph is looking like? Tell me. Hello. Are you people able to understand?
Yes, sir.
This is how the graph will look like. So let us check in Desmos whether we have drawn correctly or not. Okay. Let's check. Okay, maybe the curve somewhat incorrect. Okay. But I think this is how it should look like, sin x. Okay. So are you people able to understand? See? Yes or no? Tell me. Hello, are you people able to see? First of all, from 0 to pi, it is concave up, concave down, up to over here. See, 0 to pi, 3.14. You see, it is concave down, then concave up, then concave down, and concave up. Tell me, those who are online, are you people getting?
So can you please scroll up?
Yes. Achha, wait, this was part 1. Part 2, I have not solved it yet. Part 2, it will be 1, 1. Y equal to e to the power x plus x. Number 2. Y dash will be equal to e to the power x plus 1. Right, it's always greater than 0. Hence the function is, hence f is 1, 1. Next, number 3. Yeah, number 3 is very easy. Wavy curve f of x is equal to 0 for x equal to 1, 2, 3. Hence it is many 1. Tell me. Those who are online, are you people getting?
Yes,
Next.
sir.
Many 1 functions. Many 1 functions. Or you can say not injective. Many 1 functions. A function f maps A to B. A function f maps A to B is said to be many 1 if two or more elements of A have the same f image of B. Okay, everyone. If two or more elements of A have the same f image of B. Okay, everyone. For x1, x2 belongs to A, f of x1 must be equal to f of x2, and this implies x1. But x1 is not equal to x2. Okay. Let's see, everyone. The second one, this was many 1. This mapping is many 1. Okay, many 1. Next. This is also many 1. Okay. For example, f maps R to R. F of x is equal to fractional part of x, comma f of x is equal to mod of x. So if a function is not 1, 1, then it is definitely many 1. F of x is equal to ax square plus bx plus c. A quadratic is also many 1. Note, all trigonometric functions are many 1 and vice versa. Oh wait, all trigonometric functions are many 1. Next, number 2. A function is either 1, 1 or many 1. It cannot be both. Hence 1, 1 mappings plus many 1 mappings is equal to total number of mappings that can be defined, which can be defined from set A to set B Okay, total number of mappings that can be defined from set A to set B. Next is onto function. Onto function, or you can say surjective functions. Surjective functions. Okay, that is codomain is equal to range. Right, before also I had told you what are surjective functions. If codomain is equal to range, then the function is surjective. So if the function f maps A to B is such that each element in B codomain set is the F image of at least one element in A. Of at least one element in A. Then we say that F is a function of A onto B. F is a function of A onto B. Okay. So basically the codomain set should be exhausted. Okay. There should be nothing left in the codomain set. Are people getting, those who are online? Note, if codomain is not equal to range, then the function is into. Okay, so
So
a
can you
function.
scroll a bit up on the onto definition?
Yes. So either a function is onto or it is into. That means total number of onto mappings plus total number of into mappings will be equal to the total number of mappings. Done, Rasheshwari?
Yes, sir.
Okay. Next. So question number 4, I guess, right? What is it? 3 or 4? What is it? 4. 4. For this one, raise your hand. Okay, 4 part 1. F maps R to R. F of x is equal to 2x plus 1. Is 1 1 or is onto or not? Raise your hand. Don't speak up in between. You have to tell me it is onto or not. Raise your hand. Yes, for this one. Rishabh, tell me.
So onto.
Onto. Right, everyone? Very simple. Because the range is R, right? Range of F is equal to R. Next. Many on 1 1 it can happen, no problem. Okay. Part 2. F maps R to R plus F of x is equal to e to the power x. Raise your hand. 1 1 or not? I mean onto or not? Yes, for this one. Or if tell me.
So onto.
Onto. Range of f is equal to r plus only. This implies f is onto. Part 3. F maps r plus to r. F of x is equal to ln x. Tell me. Onto or not? Yeah, Shashwato, tell me.
So onto.
Onto. Just find out the range. Range is equal to R. It is matching with the codomain set. Therefore, F is onto. Next. So how will the diagram look like? Diagram of onto mapping. Diagram of onto mapping. Okay. How will the diagram look like? Pay attention. Is this onto? Tell me. Yes.
Yes, sir.
Is this onto?
Yes, sir.
Is it onto?
No, sir.
No. Next. Next. So lastly, we have into mapping. Into function. Okay, that means range will be a proper subset of codomain. Range is not equal to codomain. Range will be a proper subset of codomain. So till now, anyone having any doubt? Tell me. Shinika, Adrija, Madhurjo, anyone having any doubt? Rito, Rasheshwari, and Vesha. Rishabh, you have understood everything till now?
Yes, sir.
Okay. If F maps A to B is such that there exists at least one element in codomain which is not the image of of any element in domain. Okay, then f of x is into. Okay, like you see this one. Okay, or this one also. These are all into mappings. For example, f maps R to R, f of x is equal to fractional part of x. What is the range of fractional part of x? Somebody tell me what is the range? Raise your hand. Yes, Ritam, tell me. 0 to 1 closed open. You can see, right? The range is a subset of R. So of course, here range is a subset of R. So F is onto. Similarly, f maps, sorry, f is into. Similarly, f maps R to R. F of x is equal to box of x, signum function of x. Okay. Ax square plus bx plus c, a quadratic, R onto functions. Okay. Next.
So into function.
Oh, into functions. Question number how much? 5. 5. Okay, again raise your hands. F maps R to R. I mean, classify as into or onto. Classify as into or onto. Okay, F maps R to R. Number 1. F of x is equal to 2x plus 1. Raise your hand. Number 2. Yes, Rishabh, tell me.
So onto.
Onto. Next. F of x is equal to x minus 1 into x minus 2 into x minus 3. Raise your hand. Into or onto? Yes, Shashwato, tell me.
Sound 2.
Onto. Number 3. F of x is equal to box of x. Actually, box of x we have already given. Box of x. F of x is equal to sin x. Raise your hand. Second one onto. Because how will the graph will look like? Pay attention. If you people have any doubt, you can ask me now. Tell me. How will the graph look like? It will look somewhat like this. Wait. So see, range is all real, no? It's a cubic. Are you getting? Range of the function is all real. Is clear, Shana? Next. F of x equal to sin x. For this one, Shrijita, tell me.
So it's into.
Into. Because range is minus 1 to 1. It's a subset of R. Number 4. F of x equal to e to the power x. Tell me. Into or onto? Yes, Ritam, tell me. Into. Into. Okay. Number 5. F of x is equal to. Achha, for this one, everyone write your answers, okay? No need to raise the hand. X square into signum function of x. Write your answers. I want everyone to answer. You have to tell me whether it is into or onto. Into or onto? Yes, Adija, Adrito, Hori, everyone is correct. Shinika, your answer is correct. Ronak, correct. Shashwato, check your answer again. Rishabh, check your answer again. Rasheshwari, Shumangi, your answers are correct. Agniva, your answer is correct. Anvesha, right answer. Shayasi, right. Shomli, right. Joyatra, your answer is correct. Yes, Abhigyan, right answer. Madhujo, Shwankit, Shirita, tell me, what is this? Into or onto? Yes. Madhujo, there's a spelling mistake or no, it's correct. Shomli, right answer. No, Abhiksha, right answer. Well, into or onto? Okay. Over here, f of x is equal to signum function of x square into signum function of x. Can you people understand that f of x is equal to x square when x is greater than 0? It will be equal to 0 when x is equal to 0. It will be equal to minus x square when x is less than 0. Okay, so can you people understand that range is all real? Therefore, f is onto. Is it clear? Rishabh, Shashwato, are you people getting?
Yes, sir.
Yes, sir.
Okay. We can do another one. Question number 6. F maps R minus plus minus 1 to A. F of x is equal to x square upon 1 minus x square is onto. Find A. Find the interval A. Solve. Okay, so everyone see, there are two methods to
No,
solve.
sir, wait.
The sending.
Send. So Arif, check your answer again. Yes. Think Adito, your answer is correct. Vipsha, check your answer again. Shashwato, there's a slight mistake.
So minus 1 is open.
Achha, then it's Rasheshwari, there's a slight mistake. Adrija, check your answer again.
So minus 1 is open. I just saw
Okay.
it.
You people are helping others also. It's good to see. Charity work.
No, sir, I was just about to tell you only. After typing only I
No,
saw.
not only you, Shashwata also. Doing some charity work. Adrija, right answer. Orib, right answer. Now everyone started giving open brackets. Anyways, Shubhangi, right answer. Shamili, that is a slight mistake. Okay, Adrija, check your answer again. Okay. Shujita, right answer. Check your answer. Okay, Madhujo, in between there will be union. Okay, everyone pay attention. F maps R minus plus minus 1. F of x is equal to x square by 1 minus x square. So basically we need to find out the range. If range is equal to codomain, it is a surjective function. Ronak, your answer is correct. Okay, so everyone, there are two methods to solve. Method 1. Y equal to x square upon 1 minus x square. This can be written as x square minus 1 plus 1 upon 1 minus x square. This will be equal to 1 by 1 minus x square. Yes. Now it is correct. Abhipsha, minus 1. Where does x square belongs to? Tell me everyone. Where does x square belongs to? Closed 0 to infinity? Right, tell me everyone. Minus 1. Next. Now what is 1 minus 0? 1. What is 1 minus infinity? Minus infinity. So it will be open minus infinity to 1. Closed. Minus 1. Now what is 1 upon minus infinity? Open 0. And what is 1 upon 1? That is 1. But try to understand. Over here, x cannot be equal to plus minus 1. Right? So we need to exclude minus 1 first. So this can be written as, wait a minute. I think I'm making some mistake. X cannot be equal to plus minus 1. So I think I should have excluded over here only. Wait. X cannot be equal to plus, wait. 1 minus 0 comma 1 union 1 comma infinity. Right, everyone, tell me. Now I think it will be fine. 1 minus 0 is 1. 1 minus infinity is minus infinity. So it will be 1 minus infinity, that is minus infinity to 0 union 1 minus 1 is 0, open 0. So 1 minus 0 is 1. Tell me. Anyone having any doubt up to this much? Tell me. Shreyasi, are you getting? Shreyasi, Shubhangi, Shinika, are people getting?
Yes, sir.
Yes, sir.
Okay. Next. Acha, what is 1 upon minus infinity? Tell me. That is 0. And 1 upon 0 minus. Try to understand. This is 0 minus, this is 0 plus. 1 upon 0 minus is minus infinity. So it will be minus infinity to 0. Union 1 by 0 plus is 1 by 0 is plus is infinity, and 1 by 1 is 1. So it will be closed 1 to infinity. Okay, minus 1. So this will give us minus infinity, comma minus 1 open, union 1 minus 1 is 0, infinity minus 1 is infinity. Tell me, anyone having any doubt? You can ask me now. Those who are online, anyone having any doubt? Or if Rishabh, Shashwato, Shijita, is it clear?
Sir, I sent the answer.
You have sent the answer. Acha, by mistake.
Sir, I sent the answer.
Okay. Shamali, Shinika, is it clear? Acha, Shamali, you have also sent it. But have you understood, Shamali? Tell me.
Yes, sir.
Okay. Next, method 2. I have another method 2 for you people. Y is equal to x square upon 1 minus x square. Okay, everyone. So from here, I'll get y into 1 minus x square is equal to x square. So from here, x square will be equal to y upon 1 plus y. Right? Tell me, everyone. Are people getting? Since x square is greater than or equal to 0, this implies y upon 1 plus y is greater than or equal to 0. This implies, what are the critical points, everyone? We can draw wavy curve. Minus 1 and 0, right? Minus 1 should be excluded. This is how the graph will look like. Wavy curve. This implies y belongs to, range of the function will be minus infinity comma minus 1 union 0 comma infinity. So those who are online, which method was better? Method 1 or 2?
Sir, I did it method 1. I method 2.
Method 2. Okay. Next. Everyone note. Okay, one last thing I'm going to discuss, everyone. Note. Number 1. Range of even degree polynomials. Is a subset of R. Next, number 2. Range of odd degree polynomial is R. Next, number 3. We can also define total number of mappings. Total number of mappings is equal to number of onto mappings plus number of into mappings. Right? Because a function can either be onto or into. Okay. Number 4. A function can be one of these 4 types. Can be one of these 4 types. Number 1. 1 1 onto. Okay. That is injective and surjective. Injective and surjective. Okay. Means like this. Can you people understand? The whole codomain set is exhausted. Here codomain is equal to range. Is equal to range. It is also known as a bijective mapping. It is also known as a bijective mapping. Okay, next. Tell me, is this mapping bijective? Tell me.
No, sir.
Not a bijective mapping. Why? Because it is not surjective. Next. Number 2. 1, 1 into. That is injective but not surjective. Injective but not surjective. Okay. That is the last one. Okay, everyone. The last diagram which I drew. Injective but not surjective. Next, number 3. Many 1 into. If there's anyone having any doubt, you can ask me. Many 1 into. Surjective but not injective. But not injective.
So it should be many one on two.
Many 1 onto. Yes, surjective but not injective. Okay, let's see this one. This is surjective but not injective. And lastly, number 4. Many 1 into. That is neither surjective nor injective. Not injective. Tell me, till now anyone having any doubt? Those are online. Anyone having any doubt till now? Tell me. Shashwato, Anvesha, Rasheshwari, Adito, Ronak. Anyone having any doubt? Shrijita, Shreyasi, Vangi. Anyone having any doubt till now?
No, sir.
Shimika, Shamali,
No, sir.
Adrija, Abhipsha, Abhigyan. Everyone understood?
Yes, sir.
Yes.
Yes, sir.
Tanaya, Agniba, is it clear up to this much?
Yes,
Rishabh,
sir. Yes,
is
sir.
it clear? Joyatra, is it clear up to this much?
Yes.
Okay, so I think everyone we can keep it till now. Next class on Wednesday again we'll continue. Okay. Thank you everyone. Good night. I'll send everything in WhatsApp. Thank you and bye everyone.
Thank you, sir.
Yes, sir.
Thank you. Good night.
Thank you, sir.
Thank you.
Hello, sir.